All right, so we're going to talk a little bit of this is kind of some topics we've already talked about, but we'll get through it. If it's something we've already talked about, we'll kind of skip through it. But we're going to talk about data types, variables, and different expressions. All right, let's talk about data types. So there's a number of different data types that exist within Salesforce. There are primitives. Now, primitive is kind of a, we use this term, but we use it a little bit lightly because all primitives extend a class called object, which is a little bit counterintuitive. But we'll talk about what the primitives are, but they're basically images, or I'm sorry, not images, integers, Boolean strings, stuff like that. There's also enumerated lists. sObjects is a data type. A collection, lists, sets, or maps. You can create your own custom user-defined classes. There's also a bunch of classes that are a part of different namespaces, the system namespace being the most common one. And then null. Null is a keyword, and it's you can set, for instance, for instance, you can say integer I equals a null, or when you're accessing something that hasn't been populated, like for instance a field in an sObject, it will return null. So let's talk about primitives. So here are the different primitive data types. Boolean, date, date time, time. ID is a very important type within Salesforce. An ID is our record ID. Anytime that we're accessing this from within Salesforce, it's going to return the 18-digit ID of that record. Now, we can set it using a 15-digit ID, but most of the time we'll be getting it from Apex anyways, so we can set it with either a 15-digit or an 18-digit ID, but it will always return an 18-digit. There's an implicit casting that occurs between IDs and strings. We'll come back to that. There are a number of numerical types, floating point and integers, where integer, long, double, and then decimal. String and binary large object block, and then object. Now, object is the base type for all these others. So just something to keep in mind. In addition, to further stress the fact that these are, not primitives in the truest sense, they, a bunch of them have methods associated with them. So we can call methods, we can, for instance, associated with things like date, time, and so on. There's a couple of other types. There's any type. Any type is utilized in field history tracking. So if you enable field history tracking for a specific object, the data that's stored in that table is of type any type. Okay. There's also currencies associated with our different currency types. So for instance, here's some of our example primitive data types, the methods associated with them, date, date time, so we can add hours, string, we can do some manipulation, substrings and splitting and trim and so on and so forth. You must explicitly do conversions. The exception is that IDs to strings and vice versa. Those can be implicitly set. And then anytime we have, for instance, if we said, long L equals integer, some integer I, then that's okay. So as long as what we're setting it to has a greater number of byte capacity than what it is we are setting it to, that's okay. So there's also enumerated lists. They don't have the same level of customization as enumerated lists in some other languages. But what we can do is we can create an enumerated list and then using the dot notation refer to the element within or one of the available elements. A place where we use this, you'll see that system status code, we also use this for when we're doing debugging. There's a logging level, which are enumerated types. You'll see that this comes back, we use enumerated types in certain places. There's some methods associated with a specific value for an enumerated type. So ordinal, the position of the item in the list, the name returns the item as a string, and then values returns all of the names as a list of strings. So there's definitely some stuff that it doesn't allow for you to create custom methods, but there are default methods. So. All right, the all-important sObject type. So you're going to be doing a lot of stuff with sObjects in Apex. Think of an sObject being a record. Okay, so anytime we instantiate an object of type sObject, that's a record that we can then do something with. We use the API names when we're creating our objects. So here we have an example of a standard object and then a custom object. So account A equals new account, and then my custom object CEO equals new my custom object. We can also, when setting the field values associated with our sObjects, there is the constructor format where we can initialize those values. And then there is the dot notation. So there's really no difference between saying, new account where name equals Acme, and here going down here and saying a2.name equals Acme. There's the generic sObject data type. We can declare variables of this type. We cannot create concrete objects based on this type, though. So we cannot say new sObject. Okay, it always must be of one of the subclass types when we instantiate that object. So keep that in mind. That being said, we could declare a method in which the parameter is, an sObject or something like that. So then, therefore, we can then, there's actually, we have some other techniques for determining what's the underlying type of that. All right. Yeah, so we can access the, we can set the value of a field using the dot notation. Okay. One of the things it will do is you're typing in your code, it will validate it against the actual object and field names and check to see that that exists. Our metadata checking talked about how you couldn't delete a field if it's being referenced within your code. So it's going to throw back an error and say, I can't let you delete this because you're referencing it within one of your Apex classes. Okay. All right. Now, the sObject, your sObjects have some important methods associated with them. There's the add error and then the field.add error. So we are talking about previously about how you can prevent the write of a record to the database. Well, the way that you would do that is using the add error method. So if you had an account called A, you could do a.add error, and if later on in your code you performed a DML operation and attempted to write that data to the database, or for that matter, if this was a part of a trigger and you were taking a look at an individual record, then what would happen is that we would prevent the write of that record to the database for that particular instance of the record. Okay. Field add error is for associating an error with a specific field. So in this case, what we're doing is, if you think about a validation rule where we had a page level error versus a field level error, well, here the reason for creating a field level error is it associates the error with the field. One of the things that we could do is utilize that in the case of, for instance, returning a, if we're using in a Visualforce page or a page layout and we want to display a specific error associated with a particular field, we could do that by calling the field version of add error. Now, it's not actually field. For instance, if we wanted to add an error to our hello field, it would have been p.hello_c.addError. Okay. Another thing about these sObject fields is before they're populated, they return null. Now, you would think that if my hello field was not set, then p.hello_c would return null, and then if I called the add error method on that, that would return a null pointer exception. but it does not. It has, I guess, the intelligence, the interpreter, to be able to go, okay, just because this is an empty null field, it does not throw a null pointer in that case when you add an error to that specific field. Okay. There's clear. It clears out all the values. And then clone. Clone creates a copy of this record. There's actually a number of different versions of this. They do shallow clones and deep clones. In other words, do you copy the underlying values? And then in addition, there's two versions of the deep clone method, which is, do we want to copy over the record ID, or do we want to not copy over the record ID? In other words, we can then insert that new copy as a, essentially a clone of the original. Okay. S-objects, so getting back to our objects and the relations that we have between certain objects and other objects, the relationship is maintained between two fields on the S-object. There's the field which references the IDs. What this is this contains sort of like that foreign key. It's referencing whatever the record ID is of the foreign record. So let me give you an example. If we have a contact and the contact does a lookup to a account, so we have our relationship defined between our contact and our account, the contact actually has two fields. There's going to be account ID, which contains that 18-digit ID of the related account record. Then there's going to be an account field. Now, the account is going to return a reference to the object, the S object, our related S object. Okay? Let me rephrase that. A reference to the object which is of type whatever that S object type is. Okay? So from that, so for instance, one of the things that we could do is from a contact, we could go out, for instance, and do a sasol query and go out and select the related account, and then from there we could access the fields associated with that account. So using our dot notation, from the current contact dot account, that then returns a reference to the object, the remote object, dot, and then the field on the account. Okay? All right. The ID field can be utilized to identify or to change which record is associated with the, so from the child we can use the ID to essentially point that child towards a different parent if we want to redefine that association. And then the S object that's returned we can then use that as an instance of that remote S object type. So now we'll talk about this when we get back into our sasol queries, but when we're running our sasol query, we're only going to populate that object instance. If we select it as a part of our sasol query, it will not be populated by default. Like I said, we'll come back to that when we get into our sasol. When being read, if we did not select, but then we accessed it. So if we said, string s equals, and then we said c.account.name, but we did not obtain by doing a select the reference to the account, that will simply return null. Now a problem would occur if we did not select the account associated with the contact and then we attempted to set the name. So if we said c.account.name equals something, that would cause our null pointer exception. So now to add another element to this, not only are relationships defined between record IDs within Salesforce, but we also have external IDs. So if you remember back to when we're creating our custom objects and our custom fields, when we declared a field of type text, number, or email, we could have also set that field to be an external ID. In other words, we have some third-party system that we are then going to use IDs from there and populate the record with those values. And we can then keep track or identify unique instances of records using those record IDs or those external IDs. So if we take a look at this code here, one of the things that we're doing is we're instantiating a new account called ref account, and we're setting the ID, the external ID for that account equal to 1, 2, 3, 4, 5. Conveniently enough, we called the field external ID. All right, we then instantiated a new contact, and what we did was we said account equals ref account and last name equals K. Then when we inserted our contact, what this does is it then takes care of defining the relationship between this contact and the account that we identified up above. So one of the things that occurs behind the scenes is anytime you create a field of type external ID, we create an index, or we index on that field, and then we can then define or define the relationship between our contact and the account based on that key, which is the value of the external ID field. So what it would do, there's one of three things that could happen in this situation. If it finds a single account record with the external ID of 1, 2, 3, 4, 5, then this will succeed. It'll fail under two conditions. If there are no accounts with an external ID of 1, 2, 3, 4, 5, this will fail. It'll actually throw what's called a DML exception. We'll talk about exceptions later. In addition, there's a third situation which is if it finds multiple accounts with an external ID value of 1, 2, 3, 4, 5, that will also throw a DML exception. Okay? Keep in mind that your external IDs are not unique by default. We do not require unique values. That's a separate independent setting. All right. Here's another example where one of the things that we did was we did a query, and we said account ref account, and we performed a sasol query, select ID from account where external ID equals, and then 1, 2, 3, 4, 5. Now this is a database query, and what we did was we selected the ID from that, we did a lookup and then selected the ID, so we populated this. This ref account really only has one field populated, which is the ID field. But this returns, in this case, this returns our S object. So now ref account has, it's now an instantiated S object. Here what we did was we said C equals new account, and then we set the account field on the contact equal to our ref account. So we define that object relationship. We also updated our last name equal to K, that's kind of unnecessary, and then we inserted our contact. Okay? All right, now this looks equivalent. It says it's less efficient because we're using a sasol query to ultimately do the same thing. Now in reality, if you test this out, it won't work. And the reason it won't work is that the relationship is being defined by the Salesforce record ID, not an external ID. So our logic of being able to define the relationship using the object reference only works with external IDs. It does not work with Salesforce IDs. If you have a Salesforce ID in this case, what you need to do is set account ID equal to ref account dot ID. Now it will work. Okay? So jumping back to here, so here we have our account. It's a new account. Yeah, we're inserting A, and then here we are properly defining the relationship between our contact and the account by setting the account ID field. So anytime you have a Salesforce ID, use the account ID field. Here, notice that we're doing a couple of updates at the bottom of our code on line 10 and line 11. What we're doing here is we're inserting a contact on line 10 and we're inserting an account on line 11. So this is just a tricky way of inserting an account, but at the end of the day, the type is of account. Okay? So. All right. There are three types of collections within Apex. There are lists, sets, and maps. A list is an ordered collection of primitives, or really, at the end of the day, pretty much anything. A set is an unordered collection of primitives. In addition, the primitives in a set must be unique. And then a map is a collection of unique primitive keys to anything over on the value side. So it's a key to value mapping. Okay? The values can be non-unique. All right? Collections cannot have more than 1,000 elements. There's an asterisk to that if you remember back to our governor limits. If the size of our input set is greater than 40, then we can have 2,000, so that does scale. Lists and maps may contain other collections. So going back to, we can have multi-dimensional collections, okay, 5 levels deep. One thing to watch out for is collections do not support adding or removing values to them while you are iterating over that collection. So it does not handle that situation where you're changing the size of the list while you are, for instance, going through a for loop. Here's an example of a list. So it's ordered, so we have indexes. Index 0, 1, 2, 3, and 4. It says red, orange, yellow, green, blue. Because they aren't required to be unique, we could have index 5 equal to blue or some other value. Okay. The syntax that we use is we can use list and then the angle bracket, the type that the list would contain. And then we instantiate a new list, and once again we specify the type that we're creating. Okay. We can also, here's some notation showing us how we're creating a list of sets. Okay. There's a bunch of methods associated with lists. So add, remove, get set at specific locations. Check to see the size of it. Okay. And then here's some code. Notice that on line 7 at the bottom, we're using that array notation to reference using item 3 within that list. We can reference using that notation. Okay, but like I said, the thing to always keep in mind is at the end of the day, it's not an array; it's a list. Okay. A set is unique primitives, unordered, unique primitives. Okay. So we instantiate a set very similarly to a list. What we do is we say set whatever equals a new set. We can also, this is another place where we sort of take array notation when we initialize the members of that list. We can use the curly braces to identify those initial elements. In terms of methods that are available, add all takes, the difference between add and add all is add is a single thing and add all is you pass another set and you're adding all of those to it. So, is empty, yeah, okay. Some examples of sets. A lot of the time what we're using sets for is a set is a set of IDs. In other words, records that we want to do something with. Okay. The map data type is from primitive keys to whatever values. Okay. The notation is a little bit different in the sense that we have to declare the type of the key and then the type of the value that we're mapping to. Okay. So here's some more examples. By the way, one of the things that you can do is pass a list of S objects to the constructor of a new map, and what we do is we will parse out the IDs and use the IDs as the key and the S object as the value. So it's a little bit of a coding shortcut that you'll see a lot of. Okay. Map methods. One I'd like to point out is keyset. This is something we do a lot of because if we instantiate that map with a list of S objects, we frequently want to get all of the IDs as a set, we can call the keyset method on that map. We now have a new set which contains all those IDs. All right, variables. All right, so variables, kind of already saw this, but very quickly. We have our modifiers, the data type, the name of the variable, and then we can alternatively initialize it. All right. Variables allow, we can set it equal to a null, and they are initialized as null. Okay. Static variables, we already talked about static. Static, we talked about the life cycle being continuing to live for the duration of our transaction. Right. Constants, for constants, what we do is we use the keyword static and final, and then we can both declare, and then if we wanted to, we could also initialize those. All right, a little bit of review there. Expressions, things like, you know, in this case, performing addition or instantiating. Let's see here. Yeah, pretty basic stuff. Our SOCL queries are surrounded by square brackets. So you'll see the SOCL queries. They're easily identified by those square brackets. Okay. Expression operators. Just so you know, there's three versions of equality. There's the double equals, which compares the values, and then the triple equals, which checks to see if it's referring to the same underlying object. Okay. And then there's the single equals, which is merely assignment. Okay. The double equals is kind of important when you're working with S objects, because you can utilize that to compare the values of those S objects. So we'll go through and check those field values and check to see if they're the same. It's also the ternary operator. So there's a bunch of things that are available. So, all right. Our SOCL and sasol queries. SOCL queries and sasol queries are surrounded by square brackets. Here's a few SOCL queries that we perform. Normally, SOCL queries always return a list of S objects, but they can return, if we're selecting the count, if we're counting the number of records that meet our criteria, they can return an integer. There's also, we can also set it equal to a single S object, but when you do that, make sure that you're only getting back one, okay? So make sure you have a where clause where you're, for instance, checking out a Salesforce record ID, or there's a limit one keyword that I'll show you later on. All right. So here we have, it's the SOCL queries, very similar to SQL. So select the values of specific fields from an S object type where, and then we can create a where clause where something equals, you know, some field equals something. Okay. The count, like I said, returns the number of records that meet the criteria. So let's see here. The return type, I already talked about that. It is a list of S objects or a single S object. There's an all rows keyword. What's all rows? Well, all rows, if you know in Salesforce, there's a recycle bin. What all rows does is it not only searches your active records, it also searches for records within your recycle bin. So in this case, all rows will return records which are out there awaiting deletion. There's a for update keyword, which is if you'd like to place a lock on a record for the execution of your transaction, you can do that using the for update. So that way you can prevent somebody else from writing to that particular record while you are utilizing it. So select the record with for update. That way you have the lock. Then you can update it. And you won't be overriding anyone else's changes. Sasol stands for Salesforce Object Search Language. It's how we do free text searches. We'll actually come back to talking about this when we create a custom controller. We're going to create a little text search box. Sasol is a little bit different than SOCL. SOCL returns a list of S objects. Sasol returns a list of lists of S objects. And the reason is that by default, sasol queries can search across multiple object types. Therefore, if we search for Acme, we could have hits in accounts, we could have hits in contacts, we could have hits in other types of custom objects. Okay? So keep that in mind. There's a slightly different return type. One of the things that you'll see is that we allow for binding within our SOCL and sasol queries. Binding is identified by the colon. What it does is it basically exits out to your Apex code and evaluates whatever that is beyond or after the colon as a line of Apex code. So in this case here, the first line 4, here we have select ID from account where ID equals, and then we have colon a.id. Well, this is going out to a variable called a that exists out in our code and accessing the ID value. We can also just arbitrarily, define some logic that we want to basically at runtime as a part of our query, execute this and populate it. So here, the next one, which has the colon and then a plus bc, this will simply do some string concatenation and append a onto bc. Okay. And then here, our most complex example is that we're executing the return. So this is executing another SOCL query as a part of our criteria for our where clause. In this case, it does select name from account where ID equals and then a.id, and then using the dot notation. So that would return a single S object, and then using dot notation, we access the name value of that particular S object. All right. Yeah. The reason that you know that this will only return one S object is because we're doing the lookup based on the ID. So the ID is our primary, record ID is our primary key within our Salesforce database. We can also do relationship queries. So in this case, we can select items as a part of a related list. So in other words, our children. So we could say select ID and name from the account, but then also for each account, select the last name from each related contact. Okay? We just need to use the parentheses to identify the subquery that we want to perform. And then here, yeah, there's another example, and yeah, so. Okay. You only get that which you select. So important thing to understand, you only get that which you select. So in the first example here, what we've done is we've only selected the ID. In fact, the ID is implicitly selected as a part of every SOCL query that we execute. So we've selected the ID, but we did not select the annual revenue field. What's going to happen is that when we attempt to do that math operation on the second line, that's going to be 2 times null. Okay. In order to populate or to obtain the value associated with our account, that annual revenue value, make sure that you select it. Okay. So. We can also, like I said before, we can select single S objects. So examples of doing this is using the external ID, the Salesforce ID, or that limit 1. Limit 1 is a keyword that simply limits the results to one record. It randomly picks, or whatever the first one is returned. There's also, you don't have to necessarily do limit 1. You could do limit 5. That returns 5 records, or up to 5 records, I should say. So. When you're talking about external IDs, you have to be a little bit careful, because what we don't want to do is have duplicate external IDs, which is possible, and then get back a list and then attempt to access a field on a list which does not exist. Okay. Very large SOCL query results. So first off, SOCL query results in a trigger cannot exceed 1,000 records per record submitted. Okay. Now remember that we had that scalability remember we would take the number of records that we could get back as a part of our sasol query, multiplied it by the input batch. Okay, so that scales according to the size of the number of records that ultimately fired off this trigger. Now here, when we're doing a for loop, one of the things that we can do is we have a special bulk processing. So let's say that I have a visual force controller or something, and the user clicks on a button, and it does a sasol query. And let's say in this certain case, I'm looking up related items, so a related list, and let's say that related list could possibly be greater than 1,000 individual or 1,000 records. Well, by default, because the size of my list in my controller cannot be greater than 1,000, if I got back 1,500 records, then I'd be hitting a problem because I could not fit all 1,500 records into a list whose maximum size is 1,000. Well, there's this special format of a for loop, and what it does is it takes a sasol query as one argument. It returns a list of S objects, but what it does is it processes them in chunks of 200. So if you're executing a sasol query that returns a large number of results, i.e. greater than 1,000, what you should do is use this special format where the idea is that the for each part, instead of being an individual S object, it would be a list of S objects. And that list will be up to 200 S objects. Okay? So if I had 1,500 records, my for loop would execute 8 times, 7 times with 200, and then the last time with 100. Okay? All right. So this is a way to avoid, hitting the governor limit associated with that. Associated with the limit on our lists. So, okay. All right. What I'd like to do is open up the floor to some questions, and then what we'll do is we'll explain the exercise, and you will all get to write some code. So, all right. So, are there any questions? Yes. Yeah, so we only selected ID and name, and then let's say that we only changed the name. It is not going to null out or blank out the other fields, so it's only going to perform the update for the fields that are populated. Now that being said, if you wanted to do that, if I went in here and I said, in this case we have an account, if I said account.billingcity equals null, then I perform an update on that account, it will null out the billing city because I explicitly set it equal to null. Otherwise, if it's just not set, it's going to ignore it as part of that update. So there's a subtle difference between explicitly setting a field value to equal null versus simply not selecting it and it being empty or returning null when you attempt to access it. So if I access a field that I did not select, yes, so it would return null. So if I said string s equals, and then in this case, some account a dot billing city, s would equal null.
So you can't tell programmatically the difference, but internally it keeps track of that, I guess?
Yeah, I guess, the way I would think about it is that when you are reading that field value, it's probably sort of intercepting it in some way, or I don't know how exactly it's working behind the scenes, but it's sort of going, okay, this is not something that was set, therefore I'm going to return the data type null. Maybe there's kind of a difference between x equals null on an S object versus I simply didn't populate that by selecting it. So it's behind the scenes, that's the behavior. So behind the scenes it is sort of secretly or keeping track of it. So, yeah. All right, exercise 3-1. Let me give you the background on this exercise. One of the things that we did was we moved salary information off of the position record, and the reason is that in our sharing model, field level security, when you enable field level security, it means that that user, or it applies globally to any record that that user is accessing who has that profile. In other words, you can't have contextual field level security. You can't say, hide this particular field value in this record, but show it in this record. It's either you always see it or you always don't. Okay? So we wanted to create some business logic along the lines of the hiring manager can see the salary, but a person who is a hiring manager but not the hiring manager of this employee, they would not be able to see the salary. In other words, the ability to see the salary would be contextual to the user's permissions. But we wanted to still provide the ability for everyone to see every open position. So we wanted to make the other position data available in a read-only format. So we utilize things like org-wide defaults and sharing rules and all that kind of good stuff in order to take care of the position information. But we relied on record level access for the salary data so that individual users could access it, but others could not. Now, what that means is that because all of our relationships are one-to-many, conceivably we could have a position with multiple salaries associated with it. As much as we'd like that, we don't want that to happen. So we want to prevent somebody from submitting a salary, for instance, maybe inserting or updating, where they are setting the reference position ID equal to a position ID that already has a different salary. At the end of the day, the short explanation is we want to maintain a one-to-one relationship between a position and a salary. We do not want to allow a one-to-many. So the trigger that we're going to be working on, so in this exercise we'll be working on a trigger, and what we're going to do is we're going to write the logic to check out first the input set, because we might have two salaries that reference the same position in our input set. In addition, the second part of our logic is to then query the database. So now that we've identified that there's no, or identified our duplicates in the input set, then let's go check out the database. So let's query the database and only allow the insertion or the update of salary records where there is not a different salary referencing the same position. Does that make sense? So it's okay if the same salary is referencing the same position, because there we're just doing a simple update. What we don't want to allow is we don't want to allow a different salary to be referencing the same position, because now we have that branch. Okay? So our logic is going to prevent duplicates, or I should say, not necessarily duplicates, it's preventing multiple salaries to be associated with a single position. All right? So we're going to create a trigger called salary integrity trigger. I passed around the thumb drives in which you copied over the Dev 501B contents. You're going to start off by going to the, there's an Apex directory in there, and then inside of there, there's an exercises folder and a solutions folder. The exercises folder contains the incomplete code. The solutions folder contains the complete code. What we're going to be doing as part of this lab exercise is completing the code. And if you get stuck, you might want to take a look at the solution. So don't spend too much time pondering or trying to figure things out. You can go take a peek at those solutions. They are available to you. I wanted to start off this morning just reviewing what we did yesterday, the lab exercise, where we wanted to create a trigger whereby we enforced the one-to-one relationship between a salary and a position. So just a short recap, we, by default, all our relationships are one-to-many, and we want to prevent a single position from having multiple salaries. So we created a trigger that did look for duplicates or at least salaries that reference different salaries that reference the same position in both the input set, and then also check the database for any of those duplicates. So let's take a look at some of that code that we worked on yesterday. So taking a look at this, the trigger that we were working on was a trigger that was associated with the salary custom object. What we did was we had it fire based on the events of before insert, before update, or after undelete. In other words, any time that a record would have been, would be an active record. So not only being inserted and updated, but also undeleted in the sense that it's being removed or moved from the recycle bin back into our set of active records. One of the things that we did here was we created a map of IDs to S objects. So a popular thing to do is create maps in which we map the record ID to the S object. This one is a little bit different though. This one is not using the salary ID, this one is using the position ID. So it's a slight difference in the way we might normally do it, but then that is what our uniqueness is, our unique key is supposed to be based on the position ID, not based on the salary ID. In addition, we have a list of duplicates that we can then use later on to remove them from our, when we perform that lookup in the database. What our code does, once we get down to the part where we're processing the contents of trigger.new, is we iterate through our list of new records that are about to be either inserted or updated within the database. And what we do is we check to see, well, first of all, does this salary reference a position? We only want this to, only want our logic to execute if we're referencing a position. And then what we do is we take a look at our position to ID salary map, and we check to see, using the contains key method, to check to see if there's already an existing entry on this map for this particular position ID. Keep in mind that it's the position ID, which is our unique identifier. If not, then we're going to place the current salary with the reference to the position ID on that map. In the else condition, if we do find a duplicate, we do two things. We add an error not just for the current record, but we also add an error associated with the existing record. So our logic is not simply to identify the second record as the duplicate, they're both duplicates. Okay, so we're going to add errors to both of them. Then we add it to this list of duplicates, and so later on we can remove that when we do our database lookup. So that's the first part of the code that you worked on. So you worked on the part where we're looking for duplicates in the input set. The second part of the code is where we're looking for duplicates in the database. Roughly, our logic is that we're checking the database for existing salaries in which the salary ID is different, but the position ID is the same. Okay? So we're going to execute our for loop. One of the things you might notice is that we have two for loops. We have our bulk processing for loop in case we get back more than 1,000 results as a part of the sasol query that we're performing. So the select ID, position _C, and name from the salary table or the salary object. Here what we're doing is we're getting that salary ID, and we are getting the position ID of the related position record from the database. Also, I'd like to point out another thing that we're doing, which is we are, in our where clause, notice it says where position, so the position ID being referenced from the salary is in the key set of our position ID to salary map. What the key set does is it returns a set of those position IDs, and what we're doing is we're going to get back now multiple records where the salaries contain the position IDs which were in that input set. Key thing to understand here is we're able to do a bulk query as opposed to doing an individual one-off query where we might have said position _ equals and then possibly iterating through and setting that equal to a single position ID. Then finally, what we're doing in our final if statement at the end is that we're checking to see Okay, so if we found a salary that's referencing the same position ID, does it have a different salary ID? So if we have the same position ID, but we also have the same salary ID, that's totally fine because we're simply doing an update to an already existing salary, and it's the same salary. Our logic is that we only want to prevent the duplicate if we have the same position but a different salary. So here what we're doing, the key piece here is if the salary ID does not equal the ID of the one in our map. So the one we got back from the database query that we performed above, and then the second one is our map, which represents our input set. Finally, if it does match on that, then what we're going to do is we've identified a duplicate, and we're going to prevent the insert of that particular salary. Okay. Are there any? I want to open up the floor to. Are there any questions about anything about this lab, or any of the way that worked, or any of the syntax stuff that's been introduced? Yeah, Lou. So the question is. In the part of the line where we're referencing this position ID to salary map, dot contains key, and then here we have salary dot position double underscore C. Well, what is that position double underscore C returning that's relative to our salary? Well, what it does is position double underscore C is the name of the field which is defining the lookup relationship from the salary to the position. We can actually go out to the schema browser. So here under if I can scroll down to the salary, we can get that the name of that field being position double underscore C. Like I said, this will return the 18-digit ID of that position object. Now there's also position double underscore R. Okay, which is a different thing. If in our sasol query, if we would have selected position double underscore R and then some field name, we would have obtained an object reference. Then we could have then used that, much like any other S object. We would have had salary dot position double underscore R, and then we could reference a field either by setting it, or if we selected it, we could then access that variable that we got back. So there's a little bit, you got to kind of get used to the difference between the double underscore C, which returns an 18-digit ID, that's our unique key, and then the position double underscore R, which is that object reference. Lou, did that answer the question?
Yes.
Okay, great. Dan, did you have a question? Or? Yes. So the question is, can we use double underscore C to reference possibly reference the fields on the remote object? And the answer is no. The position double underscore C ends there. That is the name of the field. It returns the ID. We cannot then use that as to then expand that to drill down on the remote object. We would have to select position double underscore R and then specifically select a field from that so that we have something from there so that we have that S object. So anytime you want to reference, have an object reference to that remote object, always do the double underscore R. So, in addition, another tricky thing that you kind of got to get used to is that it's the name of the field, even though the name of the object is position double underscore C. It's just a coincidence that we name the field position double underscore C. So an example of where the field would differ from the object name. Think about on the position we have a lookup to the user object, and we called it hiring manager. Therefore, the name of the ID, we could access the ID of the user record by accessing hiring manager double underscore C. We could obtain a reference to that remote user record using hiring manager double underscore R. In that case, that's an example of where the field name differed from the object name. So don't get lulled into thinking that the field name in a lookup relationship will always be the same as the object name. They both use the same syntax from the standpoint of being double underscore C, but they are unique names depending upon what you're looking at. Any further questions? Okay, then let's continue. One of the things we get to start off the day with is our module review. And this gives me an opportunity to pick on people in my audience. So does anyone remember where we left off in terms of Ray? You were the last one? Or you were it's your turn? Okay, all right, brave, brave man. So what are the different data types for apex variables? So our different data types are primitives, and there are many primitives. There are collections, there are enums, there are user and system defined classes. There's also null is a type. So very good. David, what are the three different types of collections? How are they different? Very good. So the three types are a list, a map, and a set. A list is an ordered collection of non-unique anything really. A map is a map, for lack of a better word, it's a collection in which we map a primitive key, which must be unique, to a value, which can be anything and also non-unique. And then finally, our set is a collection of unique primitives that are unordered. Very good. What are the keywords used to declare a constant? So Todd? Two keywords. Static final. Very good. So there is no sort of const or constant keyword. There actually is, but we don't use it. There is a CONST that's actually a reserved keyword, but it hasn't been utilized yet. So static and final are the two things there. What special characters are used to surround a sokol or sasol query? So Zhang. Okay, yes, very good. So the square braces or square brackets. All right, it's early in the morning. Okay, so question number 4. What special characters are used to, what is the maximum number of rows that can be brought back by a sokol query? So Herman? 1,000. 1,000, yeah. So the limit is 1,000. There's a couple of exceptions to that. One of the exceptions is that we have, remember our special for loop? It processes in batches of 200. We'll come back to that. But that allows us to get past that. And then there is the exception to the governor limit, whereby in a trigger, it scales according to the batch size. And that was the up to a multiple of 5, depending upon the size. Okay?
For more information on Salesforce.com training and certification, please visit www.salesforce.com/training.